So here are the learning goals. This is what I hope you come away with, okay? I hope you come away and this is why, you put into groups that thinking is socially constructed, and that forms of representation determines how one thinks, what one thinks, and what one produces. What that means is that if we're going to do an ethnological study of your communities, your respective communities, and I give somebody a camera, I give somebody else audio recorder, and I give somebody else brushes and canvases, and I say, go out there and study your community and come back with some sort of report for me with those instruments. The person with the video, the video camera will come in with something very different. They will think according to that tool. The person with the audio recording equipment will think differently, and the person with the paint and brushes and canvas will think very differently. So the form of representation determines what one thinks, how one thinks and what one thinks and what they produce. That is to say, and if you turn that into math, if I only give you procedures, and you memorize those procedures, that's the only way you're going to think. If you think conceptually, if I teach you how to think conceptually, if I teach my students how to think conceptually, they will think different. They will represent things different. Now, if I add to that component the writing component, because when you're writing, you're actually carrying on a dialogue within yourself, and you're making connections and you're finding patterns, you will think differently. You will produce things differently. So that's what the writing is about. The writing is not to get over a better score in the park for me. It's so that you can think better and think more effectively, think more clearly, and communicate that much, much better. You see, that's what it's for me. So if you only give procedural understanding to students, they'll pretty much be one-dimensional. So you're teaching them to think how you're thinking. But if you're able to think conceptually and use images and understand the concept that governs that problem, and understand the facts clearly, use mathematical language and the procedure, because I'm not advocating do away with procedures and you're only going to teach concept. You cannot separate the concept from the procedure. It's like trying to separate white from rice. You'll destroy the rice. You can't. Okay, it can't be done. So, and you'll see this in as we get into the problems. So the next one is learning to write builds on specific thinking tools: images, concepts, facts, language, and procedures. Like I said, those are thinking tools. But then you use those same tools to be able to communicate. That's what you're doing. You're using those same tools to communicate. Okay, so for example, well, let me do this just real quick. If I do this, what is that? Well, it's not a cat, is it? It's an abstraction of a cat. It's a drawing of a cat. It's not a real cat. It's an abstraction of a cat. The real cat comes in a little furry ball like this, always meowing, always asking for food. That sort of thing. But this, I just gave you a representation of a cat that I have in my head. But kids might do it what? This is an abstraction. Kids might draw the head first, and then draw the body like this, and then like this, like that. That's the same representation of that cat. But you might say, what is it? I don't know exactly what that is. Could be a dog. Could be a sheep. I don't know what it is. This whiskers give it away. Maybe it's a cat. But that is what? That is a representation of the cat. That's the image. We think with those. But you saw that as a cat, didn't you? So I just communicated that through an image. That's the concept of a cat. Not in fact a cat. Okay. So we use images, concepts, facts, language, and procedure. And I used all of this language. Now I use that procedure instead of this procedure to communicate the fact of a cat, or the concept of a cat. Okay? You guys still with me? We're okay? Well, you can see that I've given this a lot of thought. I've been thinking about this for 15 years, actually. So, writing and thinking are conscious, non-conscious processes, therefore, so is mathematics. But not only mathematics is it a conscious, non-conscious interaction between consciousness and non-consciousness, everything that we do. You're eating this muffin right now. That is a conscious, non-conscious act. You learn how to eat, when we were learning in the womb, because, they're images of the unborn infant with sucking his thumb. What is he doing? He's practicing. He's breathing in and out, the liquids in and out. And he's already got those connections between the brain and the lungs and the chest cavity that push in on the lungs and bring them out. In the mouth, in the jaw, in the thumb is all being learned. But then, when we bring the baby out and then we're trying to teach it to eat, the food just goes all over the place. Why? The muscles in the brain has not coordinated the muscles yet. And then what happens? And then we just do this. We take that cup, we drink it automatically without spilling it ourselves. Okay, but I'm almost at the age where you're going to have to wipe the oatmeal off of my. So we kind of regress. Why is that? Because of the connections. That's what you're doing. It's automatic. So all of this, when we're eating, when we're writing, when we're talking, as I'm talking right now, it's an interplay between consciousness and non-consciousness. You've heard of basketball players being in the zone. Being in the zone, the guy was in the zone. He couldn't miss. His dribbling was fantastic. His passing was fantastic. His view of the whole court was great. So how does that happen? Practice. Well, you may have to be 7.5 feet or 6.5 feet tall to play in an NBA, but in order to get in the zone, all you need is deliberate practice to get rid of those errors. You see? So it's an interplay. So mathematics, just like anything else, is an interplay between consciousness and non-consciousness. So writing and thinking, even walking, I don't have to say, okay, first step, second step. I don't have to think about those. Those are automatic. Those are non-conscious. So everything we do is an interplay between consciousness and non-consciousness. Just think this. If everything was consciousness, if we did not have a non-conscious, and this is what sometimes we call it long-term memory. If everything was consciousness, you'd have to learn how to tie your shoes every morning. In fact, you'd have to learn how to get out of bed every morning. But because we do have a non-conscious, there are many things that we do in a mundane world, in a pedestrian world, that are in fact automatic, so that it can allow us to think and do and plan and create. So if you don't learn your math facts, if you don't know your operations, if you don't understand the properties that govern those, then when you're given a problem, what happens is you overwhelm your mind. And that part of that mind is the working memory. Working memory. When I was going to school, there were only two kinds of memories, or studied. Permanent memory and permanent memory or long-term memory, and short-term memory, those two. But now, since the 70s, they've studied memory a little bit more. So they call it working memory. There's a multi-component to that working memory. There are multiple pieces to that working memory. And I'll give you an example right now. The classic example I give is, let me overwhelm your working memory right now, okay? So I want you to multiply in your head. Put your pencils down if you would. It's not that I don't trust her that you would cheat and do this. It's just that I like confidence. Okay, so now. Multiply 6.5 times 6.5. And raise your hand when you get it. Okay. Now, I hope there was some metacognition stuff going on and say, what am I thinking? Oh, it just disappeared on me. What is six? Okay, six. Okay. So how does he want me to do this? Do I do it, like an algebra? Do I do it like in arithmetic? What way? I hope that some of that was going on. Okay, now do it on your paper. Do it on paper now. Okay. So I saw most of you guys. I saw most of you guys doing it this way.
Yes.
Yeah. I saw most of you guys doing it this way, like this. How come you guys didn't do it this way? Like that. How come you guys didn't do it like that? You weren't trained that way, were you? Ah, yeah. You weren't trained that way. Yeah.
That way, but I didn't put the parentheses and separate.
Yeah, you didn't. Yeah, so this is really this. This is kind of like this. But I'm going to use this right here, and I'm going to show you how to do that in your head using images, concepts, facts, language, and procedure. So what happened with 6.5 times 6.5? Did your working memory get overwhelmed? Did it just go, whoa, okay, 6.5. Okay, 5 times 5, you said, is 25, but it's not, is it? It's 0.5 times 0.5, 1/2 times 1/2. So you say, okay, 25, and I carry my 2. Then I 5 times 6 is 30 and 2. What was the other one? Did that happen? Yeah, that happens because I overwhelmed your working memory. This is what happened to kids. You overwhelm their working memory when you give them a problem. If they don't have their multiplication tables, in this case multiplication tables, but there are a lot of other things that have to be automatic.